Alrighty, folks. Today we are going to talk about covalent bonds and the properties of those compounds. So, right here you can actually see an example of a covalent bond between two hydrogen atoms, and you'll notice that these are different from ionic bonds because instead of one atom taking the electron from the other in covalent bonds, they get shared. So, I want you to go ahead and set up your notes for today. The topic of our notes is covalent bonding, and the essential question is how do atoms make covalent bonds? Go ahead and pause the video, get your notes set up, and then we will continue. Our learning target for today is I know how atoms make covalent bonds. All right, so what is a covalent bond? It is a chemical bond formed when atoms share a pair of electrons. So we are still trying to satisfy that octet rule, that rule that atoms want to have the same electron configuration as a noble gas. And so instead, though, of one atom taking an electron from another, these atoms share the electrons, and both of them now have access to that electron. So you see with these hydrogen atoms, hydrogen wants to have an electron configuration similar to helium. And so these two hydrogen atoms come together and they are going to share their electrons with each other. And now both the left and right hydrogen have two electrons in their outermost energy level, which is the same as helium. So that allows both atoms to satisfy the octet rule. Covalent bonds are formed only between nonmetal and nonmetal atoms. So it is a nonmetal bond. What question does the previous slide answer? All right, so we actually have two types of covalent bonds. The first type is called a nonpolar covalent bond. And this means that the electrons between the two atoms are shared equally. Okay, so even though the atoms are not taking the electrons from each other, the atoms still have different levels of strength. And so, for example, oxygen pulls electrons a lot harder than hydrogen does. And so if you have oxygen and hydrogen, oxygen is going to pull the electron closer to it. So even though it's shared between oxygen and hydrogen, the electron is closer to oxygen. So a nonpolar is going to be when the electron is shared equally. So in a tug of war, this would be two atoms of equal strength. And so basically, we are talking about examples with two of the same atom. So if you have two oxygens bonded together, oxygen is exactly as strong as oxygen is. And so if they get in a tug of war with each other, they are going to be equally strong to one another. And so that's going to be our example of a nonpolar covalent bond is going to be when this atom is bonded to the same type of atom. There are other examples of nonpolar bonds, such as right here, this is called methane. And the reason that it is nonpolar is because it is symmetrical. But we're not going to get too far into that. We are instead just going to say that if things like oxygen are bonded to itself, hydrogen or nitrogen, that it is nonpolar covalent. Polar covalent, on the other hand, is when electrons are shared unequally. So if this was a tug of war, one side wins. So look, for example, here at this water, you have the oxygen, which is actually a much stronger molecule or atom when it comes to attracting electrons. So when it gets in a tug of war with these two hydrogens, it's going to pull hydrogen's electrons a lot closer to itself. It's not going to take them, but it is winning the tug of war against hydrogen. And so the electrons are not equally shared. And the result of this is that now oxygen has these two electrons closer to it. And so oxygen, this part of the oxygen actually takes on a slightly negative charge, the part of this molecule. And the hydrogens, because the electron is slightly farther away from them, they actually take on a slight positive charge. And so in a polar covalent molecule, you have these poles of charge, a negative pole and positive pole. Okay, and so examples of this include water, H2O, or if hydrogen and chlorine got in a tug of war, chlorine's a lot stronger than hydrogen, so the electron will be much closer to chlorine than it is to hydrogen. What question does the previous slides answer? All right, so whenever you have a covalent compound form. It has some unique properties compared to something like an ionic compound. So covalent compounds have low melting and boiling points. So think about the fact that water is a covalent compound. Water melts at 0 degrees Celsius and boils at 100 degrees Celsius. When we were last looking at ionic compounds, we were looking at salt. And salt, I think it melts around like 500 degrees Celsius. So you can see covalent compounds melt at a relatively lower temperature. Even something like sugar, which is a covalent compound, is going to melt at a much lower temperature than something like salt. Wax is an example of a covalent compound. So covalent compounds are found in nature as solids, liquids, and gases, whereas ionic compounds tend to only be found as solids in nature. They are poor conductors of heat and electricity, so they tend to be more insulators. The attractions are stronger between polar molecules. And so, for example, what this means is if you take a polar or two polar compounds and you put them together, they will dissolve with each other. So, for example, if you put sugar, which is a polar molecule, into water, sugar will dissolve in water because each of them has those poles on the molecule, which allows the compounds to get attracted to each other and arrange in such a way that they dissolve. So, if you have polar, it'll dissolve in polar, whereas if you try to put a nonpolar substance into a polar substance, like oil is nonpolar, and you try to put it into water, which is polar, then it is not going to dissolve because the attractions are not as strong. So this leads to the concept of like dissolves like. What question does the previous slide answer? All right, folks. So I want you to go ahead and pause this video and go on your Nearpod and watch this awesome, cute video of dogs helping explain the difference between ionic and covalent compounds and bonds. I love that. Dogs are adorable. All right, so what we're going to do now is we are going to walk through how covalent molecule or covalent bonds form. So go ahead and in your packet, you will find a handout that looks like this. So I want you to go ahead and turn to that, and we are going to go ahead and work through how covalent bonds form. Alrighty, folks, let's go ahead and take a quick look at how covalent bonds are formed. So we're going to start with chlorine. So on your packet, we have 5 steps that we're going to follow. So step 1, put the most metallic element in the middle. Well, in chlorine, we have 2 chlorine atoms, and the fact of the matter is that since there's 2 atoms, neither is more metallic because they're the same. So we're just going to put them side by side with each other. So I've got chlorine and I've got chlorine. Okay. Next step, go ahead and draw the electron dot diagram for each element. And also we're going to do kind of step 3 at the same time, which is arrange the electrons so each element can contribute 1 electron to form a bond between elements. So chlorine has 7 valence electrons. So when we draw the 7 valence electrons, we want the singleton electron to be between the 2 chlorines, okay, for both of them. So you see like that, I drew it with both single electrons facing each other. All right. So the next thing that we're going to do is that when you have those 2 single electrons facing each other, we're going to go ahead and turn that into a bond. And we're just going to do that to start by circling that. Okay. And those circled electrons are a covalent bond. That means those 2 are shared. And so what we need to do now is we need to go ahead and count the electrons. And a bond equals 2 electrons. So when we count them, I'll use this. On this one, we have for this chlorine on the left, we have 2, 4, 6, 8 electrons because the bond both of those electrons count for that chlorine. On the right, we have 2, 4, 6, 8 because those electrons in the middle also count for the chlorine that we have on the right because it's a covalent bond, so both electrons are shared. So as a result, our chlorines both satisfy the octet rule. And so what we're going to do now is we are going to replace our circle there with a dash. And so I'm just going to go ahead and draw it anew. You can also just erase it, but I'm going to draw my two chlorines with a line between them, and then the other valence electrons, and just double check. I've got 2, 4, 6, 8, 2, 4, 6, 8. For both elements have 8 electrons, and I started with 14 electrons, and I have 2, 4, 6, 8, 10, 12, 14 electrons. So there's chlorine. Let's go ahead and try CH4 or methane. So first thing I'm going to do is I'm going to put the most metallic element in the middle. Carbon is farther to the right on the periodic table, or farther to the left on the periodic table than hydrogen. This is kind of one of those weird things. Hydrogen is never going to be the most metallic element. Hydrogen will always be the least metallic. So carbon's going to go in the middle there. I know that hydrogen shows up on the top left-hand corner of the periodic table, but the fact of the matter is, for this argument, it actually, or for this exercise, it actually shows up on the top right. So it's hydrogen's weird. You just need to trust me. Hydrogen is never the most metallic. It is always the least metallic. All right, so that means I have my carbon in the middle, and I have 4 hydrogens surrounding it. Okay, and then I'm going to go ahead and draw it so that carbon has its 4 valence electrons pointing towards the hydrogens, and each of the hydrogens have their 1 valence electron pointing towards the carbon. And that means that these electrons get shared, these electrons get shared, these electrons get shared, and these electrons get shared. So now carbon has 2, 4, 6, 8 valence electrons around it, and each hydrogen has 2, 2, 2 valence electrons around it, meaning that each hydrogen has the same electron configuration as helium, and carbon now has the same electron configuration as neon. So go ahead and replace those bonds with lines. So we have carbon with 4 hydrogens around it, and we have the 4 lines here. And just like that, we have drawn our covalently bonded compound. All right, so you can see there what you should have in your packet, so make sure that that matches and you can see your bonds right there. Now, I want you to go ahead and pause this video and try to do the next 2 covalent bonds in your packet. So go ahead and pause this video and try to do sulfur difluoride and iodide. All right, so there you go, folks. If you got that, that is awesome. If you have questions about that, please feel free to reach out to your teacher. All right, what question does the previous slides answer? All right, folks, I want you to go ahead and take a 4-question ungraded quiz to see how you did. All right, which of the following is true about covalent bonds? Well, it is going to be that electrons are shared between the atoms, therefore between 2 nonmetals, and both or all atoms involved satisfy the octet rule. So it's only the first one there. Electrons are shared unequally in a covalent bond. That is going to be a polar. One side poles more than the other. Oxygen, O2, because you have 2 of the same atoms bonded to each other, that means that they are going to pull equally on their electrons, and therefore it is nonpolar. Each side of the molecule has a charge that is going to be polar because each side of the molecule has a pole, a positive or negative pole. So if you answer those questions like that, you should have gotten, oops, which one did I get wrong? Okay, so I made a mistake here. Electrons shared unequally in a covalent bond is polar. I don't know. I have the key wrong here, so I'll make sure that that is correct in yours. So that's my bad. I apologize about that. But if you answered them like I said, then you should get it correct. All right, folks, I want you to go ahead and self-assess. How well do you understand covalent bonds on a scale of 1 to 5? All right, folks. So here's what you're going to do once you are done. In your packet, you will find the covalent bonding practice. This will be the basis of tomorrow's quick quiz. So I want you to go through and do it. I think you only need to do numbers 1 through 7. The key is on Schoology, so go ahead and check that out. As you have questions, please let your teacher know. This is very similar to the ionic bonding practice, but instead we're doing it with covalent bonding. So if you have any questions, let me know. Otherwise, good luck and reach out if you have any questions.